Hi, I'm Max.
Hey, I'm Ermin.
We guys working together on a smart shoe project for ISDN 2603.
My hobby is climbing.
And I'm into 3D printing, so we decided to make a smart shoe insole for climbers.
As beginner and intermediate climbers, it's hard to avoid slippery. Therefore, we tend to rely too much on our arms, which limits our climbing improvement. And that's why we need a more statistical approach to improve our climbing skills. Also, we need to ensure that there will be emergency service available if you fall and you're unconscious, because that's how I lost our arm.
So we thought, how could we solve those issues through materials, shape, design, and a bit of electronics? We started from electronics as it would define the overall shape of the device and material choice later on. First of all, we would need pressure sensors to detect the pressure applied to the foot. This is a quite useful passive sensor which works by changing conductivity, which we covered on the course. We use 3 of those for different zones of the foot. Then comes an accelerometer, a MEMS device, which we also spoke about on the course. An ASP controller, the brain of our shoe, which we haven't covered on the course. And then comes an electromagnet vibromotor, which we covered on the course. And a battery, which we covered on the course. And weeks of effort and dozens of prototypes later, this is how we arrived to the final shape of the enclosure. It neatly packs everything in an extremely thin design. Electronics is spaced into compartments with flexible pieces in between. Everything is made of ABS with phase mode 3D printing and can be soldered together to infuse electronics inside. This rigid but flexible structure keeps the electronics safe, but we need some foamy feeling for the safety and comfort of our foot. This is why we go with TPU for the main insole. During the print of the insole, we put the electronics right inside and fuse it within the TPU platform. In this way, we securely mount electronics inside without the use of the glue. And to come up with an ergonomic shape, initially we thought of 3D scanning foot individually, but it turned out to be harder than we expected, as foot deforms when you stand on it, and basically scanning doesn't make sense. So to take the best of our materials, we literally cut the shoe insole we had into 18 pieces to replicate it with G3 continuity of shapes. And here's the result. You can apply to any shoe, and it has 3 areas of pressure detection, and also an accelerometer. When you approach a rock and want to climb it, it detects slippering with accelerometer and suggests applying more pressure and gives you haptic feedback when you reach it, so you can safely continue your journey.
If you fall, you are unconscious, the sensors will detect it and initiate an emergency call.